Hey guys, what's up and welcome to my video. So here we'll be trying to figure out how to balance chemical equations and what exactly is the process needed to get it right. Well guys, so when we look at chemical equations, we need to think of it as a type of art. And this is a very beautiful art. In my opinion, the most beautiful art in chemistry, at least for equations that is. And the main idea is that we want to have the same number of atoms in the products and the reactor side. So we need to make sure the left hand side has the same number of atoms as the right hand side. Now, so before we jump in, let's take a look at this equation, which is used for burning propane and oxygen to make carbon dioxide and water. So on the left hand side, as you can see, we have 3 atoms of carbon mixed with 8 atoms of hydrogen plus 2 atoms of oxygen, which makes, as you see, CO2 plus H2O. Now, the very first thing we need to notice is the number of atoms we have on the left, which is obviously, just by looking at figures, much bigger than the right. What do we have? So, right off the bat, we have 3 atoms for carbon, 8 for hydrogen on the left, that is, 2 for oxygen, and on the right hand side, we have only 1 for carbon, 2 for oxygen, plus 2 for hydrogen, and an extra 1 atom for oxygen, making 3 oxygens. So, what happens here? Well, my idea, at least, is to always take the atoms step by step. So firstly, let's consider looking at carbon first. On the left side, you can see that there are exactly 3, and on the right side we have exactly 1. What we want to do is make sure that the right side has 3. So how can we make how can we raise 1 to 3? Well, first we can't add the atoms, but what we can do is multiply. So we could multiply the C by CO2 by 3. So this will in turn give us 3 atoms for carbon. But of course the O2 is multiplied by 3, so that also gives us 6 for oxygen, for O2. Now, that's it. Now we have the correct number of atoms for carbon, which is 3 and 3. Now moving on, let's ignore the HA for a second. Let's move on to the oxygen. Actually, let's look at hydrogen exactly. So since hydrogen is separated on the right. On the left side, we have 8 atoms for hydrogen. On the right, we have 2. Again, using the same process, we want to multiply the number of hydrogen atoms on the right by 4 to make sure it has 8 as well. So therefore, we should have 4 H2O. And therefore, this gives us 8 atoms of hydrogen and 4 of oxygen. Okay, so let's tally up the oxygens as we have right now. So now we have 6 and 4 on the right side, which gives us a total of 10. On the left side, we only have 2 for oxygen. So what we must do is multiply the left side by 5. That's it. Okay, so here's a 5 O2. Now we have 10. So now, before we see there's another step, let's go through the whole process and see if we got the correct number of carbon, hydrogen, oxygen atoms. So on both sides, we can see that we have 3 carbon atoms. Good, check. For the hydrogen, we have exactly 8 and 8. Correct, that's done. And lastly, for oxygen, we have 10 and 6 plus 4, which is 10. And that's it, guys. This is literally how you work out, how you literally balance chemical equations. You know, this is just a simple example, but even for more complex one, you know, the main idea really is to have a look at all the figures. And sometimes, you know, there may be examples where we need to find the highest common factor. So we might have 2 and 3 on one side. Hence, you need to find 6 on both sides, because you cannot have a decimal. You cannot multiply by, say, 1.5 to get 3. You need to have whole integer values. So anyway, guys, so hope this video helped. And please give me a like if you enjoyed it. And share with your friends. I'll be making plenty more chemistry style math-based equations, math-based videos. And if you want any more questions, or anything you want to say, or if some things ain't clear, then just drop me a message or leave a comment below. And all I want to say is have a nice day, guys. Ciao.